Hi, this time we will complete the analysis of the circuit C, right? We got it up to the W wire. This is what we got before in one of the previous recordings. So now we will complete it to the end, adding the futures and the gates that you've got down there in the second section of the circuit. So the mission is from the circuit to be analyzed, develop the general circuit equation from which, if you like, you can come back to the circuit. Remember that this equation is special, is the one that describes specifically this circuit. So it is not simplified in any way. It is like that. So you can go back if you like. So from this general algebraic equation, we will go through the method 3, which consists of, you see, using pen and paper and following Boole's algebra in one way or another by means of an intermediate result consisting of sum of products, or the other one, product of sums. That depends on the layout of the circuit. So in one way or another, we will get this product of sums of the sum of products, from which we can then later add the missing variables using one strategy or the other, and so that reach the truth table, but by means of obtaining the product of maxterms. So going through the product of sums to the product of maxterms like this, because the product of maxterms is already the truth table. Or perhaps, depending on the way that you are going to simplify the circuit and this other strategy, you get something equivalent, which is the sum of minterms, from which you can at the same time get the truth table, right? So this is the circuit C, okay? And we did it as I have presented here. We did it up to the wire W. So now we can continue to the end. Let's see what happens, because that's the point. You are going to solve the circuit not with a repeatable method or something that you could rely, but in your own way, by hand. And this means that we will find whatever. Some people will go in one way, another in the other. So the final equation, the final simplified equation may be different from one student to the next. So that is what we are going to do now, to solve the circuit, not the circuit key, but the circuit C, by means of the method 3. Okay? And remember, that's the good thing here. You have to have in hand that possibility to check your results using other methods. That is going to give you an advantage here, a real one. Okay, because all of this, especially at the beginning, is very tricky, and you never know if what you are doing is right or not. So a good thing here, as you see, is organize your plan, your problem, your project all the time in the same way, having in your hand several options. Like now, you have up to 4 different methods to reach the final truth table of this circuit C. This is an advantage. I can tell you that once and again because it's very important. Alright, so let's just start. Because I don't know, for example, if you go naming the wires the same way we did with the wire W, now you can name the T and the Q and the Z, for example, to name some of them. So the C, you see, remember that now we like to let's find the general equation of the circuit. The general equation from the one from which you can go back to the logic diagram that you've got here. So let's try to find it. So the C, the C is going to be a function of D1, D0, A and B, and it's going to be, easily W. See, you see it very well. W and Q. And at the same time, this Q is just, so because of the Q is yet another and, so you can write very well here W, you know, and now this gate here, T and Z. That way. In some way, the parenthesis is not necessary, but here it is placed to find this emphasis, you know. The emphasis of the parenthesis in some way means a two input and. That's the meaning of the parenthesis here. Okay? That's the meaning of the parenthesis. So you can continue now in some way, because the W is already solved from a previous example. The W was, now let's continue with a Q, or what is the same with the T. So the T is going to be something like this. The T is going to be D1 naught, or D0, or A, and everything not, and another time not, because this is the T. And finally the Z. The Z is going to be D0 not, or A, and now you've got here a parenthesis, and finally, you know, and with a B not. That's the term that you've got up to this point. Now you can just OR with A, like this. So now you are here. And finally you can get the last term, which is, you see, D0 and B. Right. So that goes connected here. So you have a OR with this term, D0 B. So that is the term that you've got here as Z. You know, this is a 3-input OR, this is a AND, that's the way it is. So in the end, finally, the equation that you are trying to find, the general equation, looks like this. C is the function of D1, D0, A and B, and becomes this term, and this term is going to look like this way. A naught, or B naught, and D0 naught, everything naught now, and D1 naught, A and B naught. Okay, and now here you are a parenthesis, a bracket if you like, which is a AND with T, and T becomes that term, D1 naught, or D0, or A, and everything not, and again not. Okay, and finally there is another AND with this term Z. And this term Z, I will place it here, again is, you know, it's like that, you see? You can do anything because it's a OR and then another OR. If you like, to make clear the two input ORs, perhaps you should do something like this. Short A, or A, so this parenthesis is required here to signal this kind of two input OR instead of the 3-input OR. So this term, or the other one, right? So something like this. So now you can write that as, if you like, another bracket like this, consisting of exactly this thing. If you like, you can A or B naught and D0 naught, or A. That's the way. And now this goes in a bracket, and that's with a OR D0 B. that's the equation that you have to find the same by yourself. So just go and check if you've got this equation here as the solution of, not the solution, just the beginning of the problem, you know, the equivalent of the secant. So if you like now, you can erase the secant because you've got the equation which is exactly the same, apart from this idea of the four input and, right, which is not important in any way, but so that's the equation, okay? An equation that you can compare with other people to see if it is all right, okay? So this is the equation, right? So now let's try to apply this method of the Boole's algebra to go to a expression that I see now that is going to be based on, you know, a product of sums. So the idea now is to try to transform every term into sums, you know, into sums that you can go anding them. Like this section here, which was the W section. So remember that the W section, you did that in a previous exercise, was finally A naught or B or D0, you see, and D0 or D1, D1 or A naught or B. That was basically B naught. That was the W from the previous analysis. Remember that we went to the end and we found the truth table of this section. But now this is only a section of the big secant C. So let it be like that. You see, this is a good thing because now instead of this complicated stuff, we have two simple, you see, two simple sums and a product. So that is something that can be, this is what is going to be used to replace this factor. So now let's go to the next one, right? Let's see what happens with this factor here, okay? So this factor here, all right, may be easily arranged because, you know, it is basically not. You see, x naught, you can imagine that everything here is x. So this is x naught and then another naught. So this one is easily simplified, okay? So yeah, remember that we are simplifying to obtain a product of sums. This is what we are pretending here, like this one, right? So let's try to simplify this term. And this term is not going to be difficult because, you know, it's simply this. So this becomes D1 naught or D0 or A. That's the thing here, okay? And what about the next one? The one down there. Well, let's see what happened with this third term here. You have something like A or B naught and then D0 naught or A, and then that's it, okay? Yes, because you can get rid of this parenthesis now and then D0 B. And what is what you can do here apart from, well, let's do that. B naught, let's get rid of this parenthesis, D0 naught or B naught A or D0 B. So this is what you've got here, and can you do something here? For example, yes, I can consider this term, and I can generate a common factor, A, and so this is going to be 1 or B naught, and remember that everything which is x or 1 is always 1, right? Well, so in this way, this factor becomes simply A. That's what you've got here. So in the end, this factor is simplified as A or B naught, D0 naught, or D0 B. Something like this is what you've got here as the third term. So in the end, that's it. So, and what is this? Is this a sum? What do you think? Is this a sum? This is what you get here, going through this idea of simplifying by hand. So what is this in the end? This is not really a sum. So you cannot say that this is a sum. No, anyway, you have ors and you have ands and you have ors. This is not a literal, you know. This is a mix of sums and products. So this is not comparable to the other terms that you've got here. You've got this sum, and this sum, and that term. So what is what you are going to do here? Okay, how are you going to solve this idea? Because you remember that this is perhaps a little bit confusing, because what you want from this term is uh, sums, you know, simple sums. So now what? What do you think that goes next here? Perhaps one way to continue is to imagine that this secant or this expression belongs to a secant, right? Which secant is this? Well, we've got it here. We can represent this secant very well. You have a box and you have three inputs, and the inputs you see is A, B, and D0. So you have A, and then you have B and B naught, so you can imagine that you have B and B naught, all right? And then the same with the D. You have D0 and D0 naught. So now, what is what you've got? A, or here you are a product of B naught. This is B naught, right? B naught and D0 naught. So you have a product here of these two terms, and then you have another product here of these two other terms, which are B and D0. This is what I see here, right? And both of them are tied together with this OR, and so the final OR is that thing that you may call it, I don't know, remember the secant that it came from what? It came Z, right? This was the Z, yes? So this was the Z. So you see, one idea here is to imagine that instead of the big secant C, now you have this small secant that you got by simplifying the big expression here. So this is your new secant. So from this new secant, you can go this way if you like. You can develop from this secant. You see, all the time you need some kind of a strategy. You need a method. Because if you have this is not a sum. This is not what you want here to get the final sum of products for your C secant, right? You like to transform this expression into something like a sum of products, but you have some of them, like here, but not that one. This is not a sum or a sum of products. You have to get that sum of products inventing something, another method. So as I say, one way to do that, if you have some imagination, is to draw the secant again, because if you have an equation, you have a secant if you like, and this is easy, because if you have a secant, what happens with the secant? You can try to find the truth table, just D0, A and B, and Z. The order is not important, right here? Well, let's do it in another order, just to show you that now the order is not what you want later. The order may be A, B, and D0, doesn't matter. What you want now is to find the truth table of this little secant, this section. Okay, you may call it secant Z, because in this way, what? you may take the terms which are 0 in this section, in this table. And the terms which are 0 are going to be represented as sums or as maxterms of this mini secant. So that is what you want, a sum, right? So let's proceed in this way. From this secant, let's find the truth table of this mini secant, all right? And once we've got this secant converted into a table, we can take the zeros, and that is going to be a product of maxterms of this mini secant, which at the same time are going to be sums in this secant C. That is the approach, okay? So, if you are now in a studying a secant like this one, the secant Z, which has this equation, and you have to find the truth table Z as a function of A, B, and D0, for example. And well, you have to find something that you can recognize. And so here, this is the point. This is really not the sum that you like to have, but this is what? This is indeed, from this perspective of the Z output, right? This is a sum of products. So the only thing that you have to do here in order to get the truth table, you know, is to complete the function. Convert from this, so Z, you see, is a sum of products. Very well, like that. A, B naught, D0 naught, or D0B. This is a sum of products. So if you do not think in anything else, for example, now, this is perfectly well a sum of products. So now what you have to do is to transform every term into minterms. The products into minterms. And how are you going to do that? Well, introducing the missing variables. And you know how to do that because you know it is x is the same as x, y, or y not. If you do that, nothing happens because this is 1. So this is x1, but at the same time, this is xy or xy not. And this is a new variable in the factor x, the y, which do not exist previously. So this is what you can do here very well to transform this b naught, d0 naught, this way, a or a naught. And doing so, you get b naught, d0 naught, a, or b naught, d0 naught, a naught. You see, two factors. And the factors now are products, yes, but at the same time, if you rearrange them in the right order, you get minterms of this function because you have a sum of two minterms here. So this becomes the minterm, and because you are talking about minterms now, not is a 0. So you have zeros. No, well, wait. I'm going too fast. You see how easy it is to get confused here. Take it easy. You have now a sum of two products, right? So let's convert this into a sum of two minterms. So simply rearrange the variables in the order that you have predicted from the very beginning. You have said so. It is going to be a, b, d0. So now this is a, b naught, d0 naught, or a naught, b naught, d0 naught. That's better, right? Do you see why? So now this is the minterm. You see 1, 0, 0, or the minterm 0, 0, 0, because you are talking about minterms and the variables are not, so this is a 0. So here you are, the minterm 4 or the minterm 0 of this z. So two terms here. For example, the 0, 0, 0 is going to be a 1, and the 1, 0, 0 combination is also going to be a 1. This is what you know now. So what else? This is this term, the one that you've been analyzing now. So you can continue, well, let's keep that terms here, M4 or M0. You can repeat that again. So that's the way to learn this, repeating sometimes the same stuff so you get aware of what is going on here. That's the way. It takes some time, but in the end it works. So you've done this term now. You have converted this term, which is a product, into two minterms. So do the same now here. So this is going to be A naught, B, D0, if you like, ordering at the same time. So this is A, B, D0, or A naught, B, D0 naught, D0, right? Something like this. So now you have the minterm 1, 1, 1, or the minterm 0, 1, 1. So now you can add here two more, the minterm 7 or the minterm 3, right? So now, if you like, now you can finish the problem trying to find the minterms associated with this literal a. It is a product, but the product of a single variable. So, well, no problem. You see, you can do the same approach here. This one is solved. It has given you the minterm 7 and the minterm 3. So now let's go with the a. A is the same as a, b, or b naught. So this is a, b, or a, b naught. So now you have two of them, which at the same time will become two minterms. So this is going to be a, b, d0, or a, b, d0 naught. And the other one is going to be a, b naught, d0, or a, b naught, d0 naught. You see? So now, because you are ordering this in this way, those are minterms of the same. So this is again the minterm 7 or the minterm 1, 1, 0, the 6. This is the minterm 1, 0, 1, the 5. And this is another minterm, which is the 4. All right, 1, 0, 0. And you already had it before. So, well, so in the end, composing them all, you have now the minterm 7, the minterm 6, the minterm 5, the minterm 4, and another time the minterm 4. But you know the minterm 4 plus or the minterm form and or the minterm form is the same, so no problem here. So you have them all now. So now it's time for you know, if you like, you can annotate that as a truth table or as this, as a sum of minterms, because what you want from this circuit basically is the sum of minterms of this circuit, which is going to be the 0. I see that now the next one is the 3, the 4, the 5, the 6, and the 7. Very well. Okay, so what I'm telling you now, that the ones which are not ones here are going to be zeros. So you have 6 ones. So it happens that you have the 1 and the 2 as maxterms, right? So which maxterms? So the maxterms that you can develop here very well are this one, the maxterm 1 and the maxterm 2. So finally, your circuit, you see, your circuit becomes this list of 6 minterms, if you like, okay, or instead the product of these two maxterms, which happens to be something like z. Okay, now you see a product of maxterms is like this, the maxterm 1 or the maxterm 2, which means, considering the order, A or B or D0 and A or B or D0, and now take care of the index, so 0, 0, 1 and 0, 1, 0. This is because you are talking now about maxterms. Be careful, because if you talk about maxterms, the 1 is the one that goes not this way. So 0, 1, 0. These two terms are exactly the same expression that you've got here from the initial circuit. So now you've got finally what you wanted, which is this expression, not like this, which is nothing special, but now like this. You see, this is, in this context of the C, just a product of two sums. So finally, if you go recalling them all, okay, you have your product. Let's use another color here, for example. This is going to be the product of sums of the secant C, which is that one here from the W, A naught or B or D0, the other one D1 or A naught or B naught, the other one D1 naught or D0 or A, and the two additional ones that you found now, right? So A or B or D0 naught, A or B naught, D0. You see, this is the solution. This is not the final solution. This is the intermediate solution, what we call a sum, a product of sums for the secant C. And now, you know, we're gonna stop here. We can check this expression with other people. Let's see if everybody's got the same result, because you know that's a good point to stop. It's just a station, a train station. You can stop here and you can compare and you can see what happens. Everybody's got the same product of sums from the secant C, yes. So now we can continue with the next step, which is very pretty much the same that you did here. You can add variables, but now considering maxterms. So you have 5 terms, okay. I guess that all of them are different in some way or another, so they cannot be simplified in any way now. So from these 5 terms, you can get the final solution, because every one of the terms here, every sum is missing a variable. So you can add the missing variable from the maxterms point of view. And in this way, you have the list of maxterms belonging to the C, which is exactly the 2 table, the one that you like from the C, for the C, right? So, to finish the recording, you know, in order to finish the recording, there is one thing left here. Adding variables to the expression to every term. So you see, add missing variables. So what I'm going to do here is to do that one time, and now you can do it 4 more times, so you will get it all. So if you've got a term like this, A naught or B or D0, and you like to get a max term, you know, that is like this, because it's X is the same as X or Y naught. So if you've got that thing in mind, now you can very well write A. Imagine that all this is your X. So this is A naught or B or D0. Okay. And D1, which is the one which is missing, and now, and A naught or B or D0 or D0, D1 naught. Okay, so you see the Y is the D1 here, and this is what you've understood as X. In this way, you have an expression that is a sum that has all the variables. But now remember, you better reorder them in order to get a minterm, a maxterm. So this is going to be D1 or D0 or A naught or B. And that one again, D1 naught or D0 or A naught or B. In this way now, because the C is organized like this, you know, the C is a function of D1, D0, A and B. So very well. Now you've got here the right order all the variables in place, whatever they are inverted or not. And so this is the max term, because we are talking about max terms. If the term is like that, is a 0, right? So 0, 0, 1, 0, because it's a naught, and now the max term 1, 0, 1, 0. Okay? So very good. This is the max term 2 and the max term 10. So you have two of them from this first sum. So now you can get them all doing the same thing for the other four, so that the C is going to be a product of the max terms, you know, the ones that I will name for you. So the max terms are the max term 1, 2, 3, 4, 7, 8, 9, 10, and 12. This is the list of max terms in the second, and so you get at the same time of the max terms, you know, you get the truth table, if you like to represent it now, and you have at the same time the sum of min terms, because you only have to pay attention to the terms which are not here. If these are the terms that are a 0 in the truth table, the remaining ones are the ones that has a 1, and this is the definition of a min term. So the 0, 1, 2, 3, 4, the 5, the 6, the 7, 8, 9, 10, so the 11, the 12, so now the 13, the 14, and the 15. So this is the solution of the problem. You see, you had the second. From the second, you got this general equation. You had your time here to get to transform or to simplify this complicated equation into something more simple, like a simple product of sums, and adding the missing variables now, repeating that step 5 times, you have finally the definition of the truth table in the canonical forms as a product of max terms or as a sum of min terms, right? So this is a problem. This is a way to go through this kind of analysis. You see, I give you an example, any kind of circuit, and from this circuit you can understand the many concepts behind here: products, sums, max terms, min terms, and everything else. And you see, in some way mixed together, but I guess that this is the best way to go through. Especially, I repeat that, because you have the solution of the exercise now by means of the Boole's algebra. Right, but remember, we will insist on the secant C, or the secant W, or the secant K, doesn't matter. We will insist, because we can do that using the 3 other methods. So in the end, this expression, which is the truth table, is going to be here as a result of the section A of this project, you know, by 4 different ways. And this is, you know, this is a proposal for learning the basics of these digital systems, the combinational circuits, okay? So, good.